back. So in this video, we are going to understand the lead code problem number 1458. It's a max dot product of two subsequences. I hope you understand the subsequences, right? So there are two arrays we have given, nums1 and nums2 we have given. We have to return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. And it is saying a subsequence of an array is a new array which is formed from the original array by deleting some or none, right, of the character without disturbing the relative position of the remaining character, as we know that, right? So let's suppose if we want to create the subsequence, uh, let's suppose we have given the array 1 2 3 4 5, right? This is what array we have given, let's suppose. And if we want to create the subsequence from here, let's suppose we'll take all these three characters, 3 4 and 5, right, as a subsequence. So if we will take this subsequence from this array, it means what? This is a subsequence of this. But if I'll take 1 1 1 1 5 3, which is not, right, means the relative position should be same. We should not disturb that. I hope you understand now the subsequences. If not, please pause and go to understand these paragraph. Basically, you can go with this line. Okay. Now think that what the question exactly saying. It is saying we have given two arrays, nums1 and nums2. We can think for now, right? So these nums1 and nums2 is two integer arrays we have given, and our task is to pick any non-empty subsequence from this array and this array, means nums1 and nums2. So both subsequences must have the same length. If I'm taking three elements from here, so we have to take three elements from here. If I'm taking two elements from here, we can take two elements from here, right? So both subsequences must have the same length, right? Either you're taking from nums1 and nums2. Once you pick the subsequences from these two arrays, right, you need to multiply corresponding element, and once you multiply it, then you have to sum up. Okay, first multiply the corresponding elements and then do the sum up. What are the elements is coming, do the sum up. Then you have to return the maximum possible dot product. So let's go to understand this problem. Okay, very first, what it is saying, take subsequences 2 2 from where, from the nums1, these two and these two, means 2 minus 2 we are taking from the nums1. Then these 3 and this minus 6 we are taking from nums2, means we have 2 minus 2 and another we have is 3 minus 6, right? So we are taking from the these given two arrays. I hope you understand. Now it is saying you have to do what? You have to do the multiply corresponding element. So we have 2 and these from these two will get multiplied by these two, these 3. So we become 2 into 3. Then minus 2 and minus 6 become what? Multiply, right? So these two like the corresponding element have been multiplied now, right? Once you multiplied it, now you have to do what? The sum. So once you do the sum, right, you will get some value. So this value is nothing but the maximum possible dot product. So if it is maximum possible dot product, means we have taken the dot product and this is the maximum. So the possibility is that the subsequences can be many, right, from the these nums, right? But if the subsequences are multiples, right, many, means there is a chance that this dot product is maybe vary, right? Means there can be also many, but you have to track the maximum one. So this case defines that the dot product is keep moving, keep changing based on the subsequences. Whatever the subsequences we are picking, this value will be also get changed, right? So this is what we have to develop, guys. So we will use the dot product. How we will take the dot product? Let's suppose you're taking A and B from, let's suppose A1, B1, will say A1 and B1 from array 1 and A2, B2 from array 2. So how will you multiply? So you can say the dot product is nothing but, you can get what? You will say A1 into B1, you can say that, and A2 into B2. Like that you can say that. Okay. So it's all depends on how you're thinking, right? So what I'm trying to say means the array one will gives you A1, A2, A1 and A2, A1 and A2, and nums2 will give you what you call B1 and B2. Then you can multiply like that. Okay. Let me write here. I think I have confused you. Better I should write. Means let's suppose array A we have. So array A, if you're taking A1, A2, two pair you are taking, and from nums2 you are taking what you call B1 and B2, right? Means dot product you have to take what? A1 into B1 plus A2 into B2, like that. Then it is called dot product. I hope you are understanding clearly. Okay. This is we have to develop, guys. Okay. Now the very important part is there is a constant, right? So constant is giving, you can go through and go through that the subsequence must not be empty. The subsequence should not be empty. Subsequence should not, not should, you can say, no, must not be empty. Correct? If it is empty, simply it becomes zero. So it should not be empty. Then the given numbers can be negative, right? So what we should do, we should skip. So skipping everything is not allowed. Make sure that. So these two things we have in the constraint. So never forget these things. Now think that, okay, what are the things is very important in this part? Let me check the constant. Okay. Now think that we have an example that we have seen in this part, right? And we have understood clearly what are the things we have seen here, right? We know that we have to find the dot product and we have to track the maximum dot product. So there is a problem. If you will apply greedy, then what will happen, right? Means, can we say why greedy or simple DP will fail? Very first thing we should understand. Why I'm saying that the greedy and the simple DP will fail, right? Because first we say, why not just? Because we have to pick max values, right? Then we have to skip negative value because negative will give the less value. Then we have to think, take longest subsequence, right? If we take the longest subsequence, then so why just we pick max value, skip negative value, and we take longest value? Understand? Because if we say negative into negative, what will give? It will give you positive, correct? So you must pick at least one pair. correct? We can say because section. This is our because section. Why not we pick max value, skip negative value, and take the longest value? Because negative and negative will multiply, it will give you the positive value. So you pick at least one pair, correct? And take the longest one, right? So skipping everything is illegal. So we cannot skip because the question said skipping everything is uh, illegal, you can say, right? The question was saying that. So three things we are saying. This is why there is a concept. What is concept? This is why the concept is about classical LCS, the LCS style DP with little twist, you can say. A twist is needed. So if you are not aware with this concept, make sure that you first, sorry, if you're not aware with the LCS DP style, make sure that you go and read first this type of concept and then try, right? But if you are little aware that you have completed one or two problems, it's also fine. Okay, we know that, right? So let's come back here. So very first, what is the intuition is here? Intuition is at intuition. So intuition is at every index. Can I say I and j? If index is I and j, we have three choices. Correct? What are the choices? Choices one, if we have a pair, if we have a pair that is called nums1 at I, we can say, and nums2 at j. It means what we need to do? Nums1 at I, we have to multiply by nums2 at j. Correct? So we have to do the very first thing. Then in step 2, we have to skip nums1 at I. So when you skip it, you will say dp at I minus 1 and j, right? So we have to skip this part. Then third part is that we have to skip nums2 at j. So dp at I and j minus 1. Correct? So these three things, we have the choices that we should not forget for any index I and j. I hope you understand. So if you want to skip nums2, we have to skip it, then dp at I and j minus 1. So we have to take the maximum of these, right? What we can say? We take the maximum of these, correct? So what is a special trick? Let's build a special trick. A special trick. We can say we cannot allowed empty subsequences. Can we say that? So we must initialize dp with very negative values. That is called not zero. Okay. So this is the concept that you should never forget that. Okay. So can we say about the DP states? Yeah. So the DP state we can say, or DP table you can say, right? Okay. Let's think. If there is a DP and there is I and J, right? It means what? There should be a maximum dot product, right? Using what? Using nums at 1 from 0 to 1, we can say, not I, we can say, and nums to 0 to j, we can say that. Correct? Using what? Using at least one pair that we have chosen. So this is very important, guys. You should not ignore this part. If you will ignore this part, definitely you will not understand the code. Okay. What is saying that? DP at I and j means at every index I and j, the maximum dot product will be, we have to get, and then we have to store here. How? By using nums at from 0 to this one and nums to 0 to j, using at least one pair that we are going to choose. So we can say that it's important and we should not forget that, right? So let's talk about that each cell, that is we have each cell I and j, we can say, depends on, very first, if we have a top corner, right, it will take I minus 1 and j. Then if you want to go to the left, we'll say in the left it will be I and j minus 1. If it is going to the right or diagonal, let's go with the diagonal, it will go to I minus 1 and j minus 1. So we should think in this context. The top I minus 1, j, left I and j minus 1, and another one we will go with the diagonal one, right? Because the concept is LCS. That is why we have to go to diagonal or the left. Okay. Now think about how we'll find the pairs. So at I and j, okay, the pair is what? Nums I, nums 1 we can say, into nums 2j. This is clear, that we know. It means dp at I and j is nothing but maximum between what? There will be a pair, right? Then the pair plus dp at I minus 1 and j minus 1. Okay. Another value will be dp at I minus 1 and j, and dp at I and j minus 1. Like this, we can say that. So here we can say, even if all product are negative, we still pick the list bad one. Correct? So this is the thing we should never forget. If you forget, you will not understand. So very first, for every pair, every INJ that is called pair, you will need to find the multiply. So you have to track the maximum between the pair, either between the pair plus the diagonal thing, then this part and then this part, right? That we have seen all these things. Either you're going top, left, and diagonal. So with all these, there will be some pair will be there, right? So you should find the maximum between this, and this. So even if all the products are negative, so we still pick that list bad one, correct? So let's go to the code and we'll understand here. So very first we have given nums1 and nums2 we have given. So we'll get the length of nums1 and nums2. Then you will define the dp and an m, right? 2D array. Then what we will do, we will initialize the smallest values, right? So dp at I and j should be the max value. So we'll take the mean value, right? Negative infinity, we can say that. Integer negative infinity value will assign on all the dp elements, dp cell. Then for all I and j, we will go with the pair. So this is the combination that you should never forget. For at each every I and j, right? Remember, I told you. So on that, you need to find the dot product. This is your product, dot product. You will assign this dot product here. But if I is greater than 0 and j is greater than 0, you need to find what? The pairs. What are the pairs is there? So this pair is dp I and j. Then the pair, we can say plus the I minus 1, j minus 1, which is the maximum you will store here. If the dpij with the left or the diagonal one, so this is diagonal left, we can say, and what do you call the top one, with that you will check. So all the value you will check with, if I is greater than 0, j is greater than 0, what is the maximum one. So the maximum one will be updated, right? And finally we'll return n minus 1 and m minus 1. So this is what we have, guys, in this video. In case if you have understood the problem, please must write the time and space complexity for this problem, right, in the comment box. I'll give you the I will give you the hint, right? Let's suppose we have given two things, right? I and j, right? So if this loop is n, this loop is m, right? So this loop will go for how many? Let's suppose n times. So it will go for m times. So can we say that n into m, right? So it will come the complexity. For the space complexity, are we storing the value somewhere? Yes, we are storing the value somewhere. What is the somewhere? This is the somewhere. So please write this time and space complexity. Can we optimize this to something else? The time complexity and space complexity, must write the code and try to write the code. But make sure that you will not use the brute force, because you have to try for all the subsequences. The idea will not work, because you have to generate all the subsequences and then you have to compare, and that will give you the worst time complexity to 2 power n into 2 to power m, because you are going to try for all the subsequences. So it is impossible for the constraint that you are going to use, and that will not satisfy, right? If you're using, let's suppose, recursive and memorization, right? It will also not work, because the top down approach, the dp, it is easier to write the code, but stack overhead will come, and same complexity with the dp will work. Dp will come, so same complexity will not work. So you should try this one. You will say, okay, I will try the greedy or two pointers algorithm, that I already told you that it will fails with the negative values, right? And no optimal answer will come. I will give the guarantee that it will not work. Okay, so try with the dp, this one, and it will definitely work, the LCS concept. So dp with the space optimization, you will use 1D array in place of here, and that will you can do with for the space optimization. So I will try to cover in another video, if you know, right? But I will suggest that must go with the LCS concept, but instead of uh, matching all the character, LCS is the best. So I will suggest try with this first, and you will multiply all the numbers without anything, and you will try to pick the uh, dot product easily. Okay, So that's all I have in this video, guys. In case if you are struggling with anything, please must write in the comment section. And for any uh, questions, you must write in the comment section. And if you want the live classes right from me, you can join my online classes. And for that, you need to contact me through the WhatsApp. Thank you guys. Thank you for watching this video. I'll see you in the
Thank
next
you
one.
guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.